ever marveled at the sight of a massive airplane soaring through the skies? Have you ever pondered on the physics that allow these colossal machines, weighing hundreds of tons, to take flight? It might seem like a complex puzzle, but it all comes down to understanding the forces involved in flight. 3 key forces come into play when an airplane takes off. The first is the weight force, which is directly proportional to the mass of the airplane. The heavier the airplane, the greater the weight force that pulls it towards the Earth. Next, we have the thrust force. This is generated by the airplane's engines and serves a dual purpose. Not only does it propel the airplane forward, but it also gives rise to the aerodynamic force. This brings us to the third force, the aerodynamic force. This comes into effect when an airplane is surrounded by moving air or when it is moving through the air. The wings of the airplane, often referred to in aeronautical literature as a single wing or half wing, play a key role in creating the aerodynamic force. If we represent the aerodynamic force as a vector, it is always directed upwards and backwards. This force can be split into 2 components. The component facing straight back is called the drag force, while the component directed upwards is called the lift force. For an airplane to take off, the lift force must be greater than the weight force. This lift is provided by the wings in 2 ways. The upper surface of the wing is curved more than the lower surface. When air flows over the leading edge of the wing, it travels a greater distance over the upper surface in the same amount of time, creating a higher dynamic pressure on top than on the bottom. According to Bernoulli's postulate, this implies that the static air pressure on the lower surface is higher than the static pressure on the upper surface. This difference in pressures results in a force that pushes the wing upwards, creating lift. However, the lift generated in this manner isn't substantial. It can be increased by enhancing the curvature of the wing profile, but this makes the wing thicker and generates a significant amount of drag. This kind of wing design is suitable for smaller, slower aircraft, but not for modern airplanes that move at speeds close to sound, or even for supersonic aircraft. In essence, the physics of airplane flight revolves around balancing and manipulating these forces. The engines generate thrust, which leads to aerodynamic force. This aerodynamic force, divided into drag and lift, is manipulated by the design of the wings to overcome the weight of the airplane and allow it to take off. So, the next time you find yourself marveling at the sight of an airplane taking to the skies, remember the intricate dance of forces that makes it all possible. It's not just about Bernoulli's principle. It's about the fascinating interplay of weight, thrust, drag, and lift, and